Two things are going to come out of this question. One of them is that this equation is not set equal to 0. And when we're doing quadratic equations, it's always useful to have everything equal to 0. So the first thing I'm going to do is I'm going to move things around to make sure that at the end of the day it's equal to 0. So I'm going to say that this is 2 tan squared 2x minus the tan of 2x minus 6 equals 0. Okay? And I'm assuming everybody is on board with what I just did. All I'm trying to do is to make this equation equal to 0. Because at some point, if I can factor it, then I can start talking about the zero product law, right? Okay, now, before we go any further, is there something that we need to do with the domain that we are supposedly trying to find our answers, or in which we're supposed to find our answers? We have to extend it. No is right. In fact, we have to multiply both sides of that domain by whatever number is in front of the x. In this case, it's 2. So even though we only have to go from 0 to pi, what we are actually going to end up doing is we're going to end up actually going from 0 to 2 pi when we're searching for our answers. And when we divide by 2 at the end, which we'll need to do, it will bring it back into our desired domain. So it's not that we are saying the domain is different. At the end of the day, we still have 0 to 2 pi, 0 to pi. But we have to extend our region that we're going to look for answers so that when we divide, it comes back into the region that we want our answers to be in. So the one is 100% right. Okay, so the next thing, of course, is what? What comes next? After we've done that, so we've done that. We've extended the domain for where we search for answers. What happens next? Yes, Jeremy, go ahead. No, we didn't. No, we didn't. Nope, nope, not necessary, because this was just a straight of x. There was no 2x here. So we just are going to look between 0 and 2 pi. So no need to do that. Yes. Correct. Correct. You're welcome. Correct. Okay, back to business. What happens, and thanks for the question, by the way. What happens now, right? What happens next? I need to get some feedback from the class. Thank you, Noah. Noah's answered the last 2 questions, which tells me that we need some more participation. I'm going to use my magic X on this one. I'm going to say that it's 2 times minus 6, which is minus 12. And in the middle, I'm going to have minus 1. All right, hopefully that makes sense to everybody. It's the first number times the last number, the leading coefficient, times the constant, which gives us a minus 12. And then the middle coefficient is minus 1. So there you go. They're not Noah this time. Give me 2 numbers, apart from Noah, that will multiply to give us minus 12 and add up to give us minus 1. So 3 and minus 4, it seems like, is what we're hearing. And that makes perfect sense. Those multiply. Thank you very much, Jeremy. Thank you very much, Rachel. Thank you very much, Joel. Those multiply to give us minus 12 and add up to give us minus 1. We're going to divide both of these numbers by the lead coefficient of 2. This reduces down to minus 2 over 1. This cannot be reduced down, so leave that as it is. So here come the 2 brackets that we need. One bracket is going to be 2 tan 2x plus 3. And the other bracket is going to be tan 2x minus 2. Okay, so those are just the numbers that come from the fractions that we got. The bottom number times the x, or in this case tan 2x, so 2 tan x plus 3, then going to be x minus 2, or tan 2x minus 2. So there you go. All right, sorry, how did I get the minus 1? Kayla is asking. Okay, and Kayla got her answer from Jeremy, so we're good to go. So we're going to use that zero product law now. Here we go. There we go. So I'm going to say that 2, I'm going to sort of leave out one step. Tan 2x is equal to minus 3. Sure, everybody understands that. And tan 2x is equal to 2. All right? 2x equals minus 3 over 2, correct. Okay, thank you, Aliza. All right, so that was Aliza. Axel, what is my next line? I'm trying to eventually, oh, there's some more stuff here to erase. Hang on. Okay, what is my next line going to say after that? If the tan of 2x equals minus 3 over 2, what should my next line say as I'm trying to solve this thing? Tan inverse, okay. But what, okay, I agree, there's a tan inverse involved. Tan inverse to minus 3 over 2, okay. So, but the left-hand side still has to say 2x, does it not? Oh, sorry. Is that what the left-hand side still has to say, AXA? Yes? Okay. And here's the thing. I've always said I don't want you. Does anybody remember this? So AXA is on the right track, but what is it that I've always said? And we'll take some no negative, take out the negative. Perfect. Okay, that's what I want to hear you say. So yes, you're right. I'm going to find tan to the minus 1 of positive 3 over 2. Right? And I'm going to call this 2x prime. That's just my way of saying it. Okay? So the last thing I'm going to ask you to do now, okay, Karis was the one who said that. I was hoping, yeah, no negative. Okay, right. So Karis jumped in, but it was really Axa's question. So the last thing I'm going to ask you to do for me now, Axa, is to figure out what tan to the minus 1 of 3 over 2 is. Can that even be done? Because sometimes we had some trouble with finding sine and cosine when it was greater than 1 or less than minus 1. Can we actually do this? Can we find tan to the minus 1 of 3 over 2? Is that even possible? What do you say to that, Axel? Because remember that time that you were trying this with sine and cosine, the calculators were throwing up error messages all over the place. But is it going to do that with this? What do you think, Axel? It works. So how come it didn't work when we were doing sine and cosine? Does anybody have an answer for that? And by the way, I'll ask for that number in a second. Does anybody know why this is working now, but didn't work when we were doing sine and cosine? Okay, Jeremy, go ahead. Mhm. Okay, yeah, yeah. So when you look at the tan graph, you'll notice that it has these lines that go up forever and down forever. Right, it goes up to infinity and down to minus infinity, whereas sine and cosine bounces between positive 1 and minus 1. So there you go. Okay, so my question for you now, Axa, is what is the tan inverse of 3 over 2? Can you give me an answer for that, please? 0.9827. I'm going to take that as being gospel. I don't know. And I'm hoping that, no, wait, never mind. Something is wrong with that, Jeremiah. Jeremy, is that not the number that we should be getting? Axa's number isn't right. I'm not using my calculator, so oh, the rounding of it, you're thinking. What do other people have? Because I'm not using my calculator. Is AXA right or is Jeremy right? Which one? Which one is get that too? Got which one too? There are two answers, Harish. I don't know which one you're talking about. You got which one too? You got Jeremy's answer. All right. What do other people get? Kayla says you got the 0.9. Okay. So all right. Even though I'm not checking it, I hope that AXA can check and see that maybe her rounding might have been off. I don't know. AXA, are they onto something there, or are they all wrong? What do you say to that, AXA? Should I have kept it as that, or is that okay? All right. Okay, so that's AXA. Thank you, AXA. So let's move on. That was AXA. I'm going to be asking somebody now where I should put those angles or that angle, right? And this question goes to Jeremy. Jeremy, it's your turn. Jeremy, check in for me, please, first of all. Are you there, Jeremy? Okay. So, Jeremy, where do I put this 0.9828? What quadrants should that belong in? You think 2 and 4. All right. When you're sure, let me know. Are you sure? 100%. Okay. All right. 2 and 4. All right. So let's do that. So there and there. And again, it's always measured to the x-axis. So 0.9828 from here, 0.9828. So the question now is, Jeremy, they asked us to go from 0 to pi, but we agreed that we would go from 0 to 2 pi, which means we're going to do a full rotation, right? So we're now ready to put the actual value of 2x in, not 2x prime, but actual value of 2x. So Jeremy, what would you say is the 2x that comes in the second quadrant? How would I get that answer? The 2x in, go ahead. Think it's not, I think it's 828, 0.9828, but whatever it is. Yeah. 2, 2.1588. Thank you very much, Jeremy. All right. And we're going to go to somebody else now to get the second angle and how we're going to get that second angle. And that task goes to Ava. Ava, check in for me, please. Great. Okay, so Jeremy gave us one angle in the second quadrant, but he also said it as an angle in the fourth quadrant, which I agree with, by the way, because that's where tan is negative. We're looking for answers where tan is negative. How would I get that answer and what is the answer? Tell me how to get it and then tell me what it actually is. So one of the answers is 2.1588, which he got from taking pi minus 0.9828. How would I get the one in the fourth quadrant? And I'm always ready to give you a help if you need it. I always say that. Okay. You said it needed to be negative. No, I didn't say that. I said that, let me go with that again. When I asked Jeremy at first, what quadrants we need to put these angles in. Remember, when we took tan to the minus 1 or 3 over 2, we got 0.9828. That's what we got, right? So we needed to know where those angles needed to be put. And he looked back and saw that originally the tan needed to be a negative number. The tan of whatever it was needed to be negative. So he said, okay, I'm going to put that 0.928 in quadrants 2 and 4. That's where the quadrants, that's where the 0.9828 needs to be. So now what we need to do is figure out what those angles actually are, because the 0.928 is just how far I am from the x-axis. That's all the 0.928 is telling me, right? So he got one angle in the second quadrant, but he also said there's one in the fourth quadrant. So my question for you is, how do I get the fourth quadrant angle? That's the question I have for you. It's 0.928 away from the x-axis in the fourth quadrant. So there, back over to you now, Ava. If you need another hint, you let me know. Would it be pi plus 0.9828? Well, no, no. And let me see if I can walk you through this. Excuse me. This is 0 right here. Okay. This is pi over 2 up here. This is pi over here. Down here is 3 pi over 2. And up here is either 0 or it can be 2 pi. Okay? So here's what we're saying, Ava. I'm going to be looking for the angle that starts off here, goes all the way over here, and doesn't quite make it all the way back to the x-axis because it's short of that by 0.9828. So can you suggest a way that I can get that answer, Ava? It's the kind of thing that you should expect on the test, on the assignment. Right? I've not made it all the way. That makes more sense. Does it not, Ava? That it's 2 pi minus that number? Yes? Okay, could you work that out for us now, please? Because that's the other 2x that we're looking for. So we have one answer so far of 2.1588 that we got from Jeremy. I haven't checked it, so I'm assuming other people did check it and they got the same answer. But now we're waiting. Sorry, just double checking. 5 rounds up always. My physics is messing with me. Yes, you round up if it's 5 or more. Okay. Okay, so 5.2972. 5.2972. 5.297. Okay. Ava, I'm going to assume that you're right. I'm not questioning it. I didn't question Jeremy's either. So I'm assuming that you're both right. But the point is that these are 2x angles. These are all 2x's. 2x is equal to this, and 2x is equal to that. Thank you, Ava, by the way. So let me take Ava out. And let's ask this other person how to get the final answer. That goes to Neil. Neil, could you check in for me, please? I got something different again. Oh, okay. Okay. Oh, all right. I'm glad you're all double checking this. 5.3004. Okay. Ava, can you check your answer for me, please? I just wrote it down. I didn't check it. So can you check your answer again, please? And see if perhaps these other people may be right. So Ava, let's come back to you for a minute. Neil, please be on standby for me, please. Yeah, I got that too when I use pi instead of 3.14. Sorry. No, when you're doing any of these calculations, pi is not 3.14. That's if you're, and I keep using this analogy when I'm teaching students. If you're going to become the engineers and the bridge builders of tomorrow, I need to get you to be more accurate than using pi as 3.14. Pi is just very crudely rounded to or roughly rounded 3.14, but you want to use it pi that's in the calculator. Because when you're building things that I have to drive on or to live in, I want to make sure you're going to do this accurately. All right. So, Ava, are you now saying that you agree with the other answers or not? The answers that I got, you do? Okay, so I'm going to use that answer instead then. So you're saying 5.304 is what Jeremy is saying. So I'm going to put that in instead. All right. Okay, so 5.3004, I think is what I saw there. I'll just double check that. 5.3004. Okay. Thanks for confirming. Didn't know if I was doing something wrong. Yeah, well, we all make mistakes, and that's par for the course. Okay, so I was just about to go to Neil. I think it was. Let me check. Yeah, Neil, check in for me, please. Okay, so Neil, these are 2x answers. 2x is equal to 2.1588, and 2x is equal to 5.3004. But I'm not interested in 2x, really. I'm interested in x. How do I get x? That's my question. What I'm looking for is x. Can you tell me what to do, please? I don't want 2x, I want x. Divide each of the numbers by 2. Well done. Can you do that for us, please? And give us your answer. Both answers. One 1.0794. Actually, you know what? Let me go back and see what the question required in terms of rounding. You know what? I'll just put 2 decimal places at this point. So 1.08. And sorry, the second one was 2.65. So 2.65. And by the way, is everybody getting the same thing as Neil? Is Neil on the right track here? Can you just check in? I'm just checking in with the room here. Oh, okay. Look at that, Neil. Everybody is on the same page as you. No, to be clear, both of these answers are in the original domain of 0 to pi. Pi is 3.14159, whatever. So both of these answers are definitely within that domain, even though when we put the angles in the quadrants and did all the math, we got one answer was 5.3. This would have been more than pi, but of course we did have to divide by 2, and that brings us back into the right domain. So those are our answers. Okay? How did you get 2.65? I don't understand that part. Really is asking. Okay. Let me go back to Neil. You said that we had to divide by 2, right? So we're taking the 5.3004, this answer right here, and dividing it by 2. Have you tried that, really? 2x. Okay, right. Okay, you see now. Okay, good. Let's move this along, folks. Let's move this along. All right, let's tackle this question. Sherry and Leo are standing 36 meters apart and facing each other. Sherry looks upward, angle of elevation to a hot air balloon is pi over 4, so to give an exact version of the angle. And from Leo, the angle of elevation is pi over 3. Calculate the exact height of the hot air balloon above the ground. Sounds like a diagram would help us out with this, right? Now, I'm not going to try to draw any balloons or people or any of that stuff. That's beyond my pay grade. I cannot do that. Guess we're skipping part 2, right? Skipping part 2. Part 2. We answer the question. What's the part 2? Sorry. What's the part 2 that we're talking about? We didn't do the other one. Oh, the other equation? Aren't there 2 more answers? Why would you think there are 2 more answers? Tell me why you think there are 2 more answers. Tan 2x equals 2, yeah. So does that, why do you think, I'm so sorry. Oh, yes, you're absolutely right. Yes. Sorry, folks. You're 100% right. We didn't finish the question. We did not finish the question. Thank you very much. Yes. There are 2. Yeah, we are so focused on solving the left that we didn't finish up the right. So we do have some more work to do. So let's get this done. Let's finish this up. So tan 2x equals 2. So I'm going to go a little bit faster on this one, right? So if tan of 2x equals 2, then 2x, I'm going to say prime as usual, is equal to tan to the minus 1 of 2. We already established that it's okay to have, for tangent, numbers that are bigger than 1 or less than minus 1. So I do need your help. I don't have my calculator handy. What is 2x prime equal to? What is tan to the minus 1 of 2? Give me the usual 4 decimal places for now, please. The usual 4 decimal places. Tan to the minus 1 of 2. Okay, so 1.071. 1.071 is what I'm getting. Everybody seems to be on the board with that. I'm going to draw my quick grid here. Where do I, and 4.2, okay, hold on, Jeremy, we're not ready for that yet. Where do I put this angle? What quadrants should I put this angle in? Right, I want it for tan. and I want it to be when tan is positive this time. So which quadrants? Quadrants, there has to be a 1 in front of the, hold on, what's going on here now? 1.01. Oh, got you. I got you. Yeah, thank you. Thank you very much. I'm hearing 1 and 3. So I'm going to agree with that. So 1.1071 and 1.1071 over here. First quadrant. Okay, Neil, make sure you come back within 5 minutes. It's 2:03 right now. So there are two answers that are going to come from this. Again, we're going to do a full rotation. Why? Because originally the question says 0 to pi, but we have to go 0 to 2 pi. So we're going to do a full rotation. All right. So what are the actual angles that we need? We need 1 in quadrant 1. I think everybody agrees with that. 1 in quadrant 1 is just going to be 1.1071. And how do we get the second angle, right? Again, I'll do this fairly quickly now, so anybody can answer. How do I get the second angle, which is in the third quadrant? Add it to pi, okay? Could you do that for me, please, quickly? What is that? Maybe that's the answer that Jeremy was kind of giving us away a while back. What is it? Pi plus 1.071 is what? 4.24, 4.2487. 4.2487. And then those are my 2x angles. So for x, I'm going to divide each of these numbers by 2. Quickly, please, anybody, give me those two answers because I need to move on. 0.55, I'm hearing, and 2.12. Okay. By the way, I'd like all of you to double check those answers. Neil is back. That's good, Neil. Look at Jeremy's answers. Everybody on board with that? Because I'm not checking it myself. I'm hoping that Neil is right. All right, we need to divide 4.2487 by 2. Yeah, there we go. Okay, good. Let's move on. Let's move on. And I apologize. And I usually like to put all my answers together. So 0.55, 2.12. And so we got the 4, 1.08, 2.65. 1.08, 2.65. So all my answers are together in one spot. Let's move along. Let's move along. And all answers, by the way, are in that, as we said, in that 0 to pi range. Okay? All right. Trying to get to this question. Let's go. Shari and Leo, assuming they're two friends, are standing 36 meters apart. I guess they're doing the social distancing or something. And they're facing each other. Shari looks upward. Angle of elevation is pi over 4. Leo is looking upward. His angle of elevation is pi over 3. And from that, we're supposed to find the height of the balloon. Uh-oh. All right. Let's see if we can draw a diagram for that. That's the ground. The balloon is, let's say the balloon is right here. In fact, I use a dotted line. Let me use a dotted line for it. No, that's not a dotted line. Let's try that again. Dotted line. Dotted line. Okay. Angle of elevation, let me remind you, is the angle that's measured from the horizontal looking upward. So let's say this is Shari over here. Let's say this is Leo over here, using SNL to represent both of these people. When Shari looks upward, her angle of elevation is pi over 4. So let's say this is pi over 4. When Leo looks upward, angle of elevation for him to the same balloon in the sky, right, is pi over 3. They're not equal. This is not a nice isosceles triangle. This is just a scalene triangle. Scalene meaning that all the sides, all the angles are different. The only other thing that we know is that they're standing 36 meters apart. So this distance from one end to the other is 36 meters. These are important. Now, when we're asking for the height of the balloon, we're talking about going straight up to the balloon in the sky. And that's a vertical distance. So let me put another dotted line in for that. Right? And we'll call this height x. And by the way, why don't we put a little right angle on either side of that? Because when you're measuring a height, you measure it vertically at right angles to the ground. Okay? And that's what we need to figure out. That's exactly what we need to figure out. So that's Shari on one side, Leo on the other, 36 meters apart, facing each other. Shari looks upward, sees the hot air balloon, or angle of elevation pi over 4. Leo looks upward, angle of elevation pi over 3. What's the height of the balloon? And the answer needs to be in exact form. Uh-oh. Exact form. Exact height. So no decimals. No decimals. All right. Any ideas as to how we could do this, by the way? Does anybody have any notion as to what direction we could go in? Anybody? I'm not going to spin the wheel right now. I'm just throwing it out there and asking if anybody has a inkling, has a thought as to how we could find the x from that. Because you can actually find that height based on that. Solve for the unknown angles in the right angle. Okay. Yeah, we could do that. And then what? Could you scroll to the Q? To the Q. Oh, the Q. What Q are we talking about now? Question. Oh, okay. That Q stands for question. Okay, all right. There you go. All right. So, okay. So I hear what you're saying. Read it again. Okay. So I hear what you're saying. You're saying that we could find the missing angles. And I agree with you. We could find the missing angles. That's not too hard. But what is that going to do now? Well, I mean, what do we, yeah, let's come up with a strategy here. Let's see where else we can go with that. So, okay, let me answer the question that you just asked. Right? You're saying, not asked, but you suggested, I should say. We could figure out this angle up here. And we could, let me put another color on that actually. We could figure out that angle. Right, that's not another color. We could figure out this angle. We could figure out that angle. That's not hard. We could do that. Would we use sine and cosine? Yeah, I'm thinking sine and cosine and tangent and things like that might be useful. All right. Tell me how, Jeremy, expand on that. Mm-hmm. 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 Okay, okay. And I like the thoughts. I like people coming up with ideas. One of the problems that we have right now is that we don't know what this side here is. We know the whole thing is 36, and before anybody thinks this is the case, because I dropped a line from the top down to the base does not mean that I split this exactly in half, right? So it's not like there's 18 on either side of this. Do not make that assumption, right? We don't know this side, and we certainly don't know this side over here either, right? So I hear what you're saying, Jeremy, but we're kind of running into a roadblock where neither of those two sides is known. And we don't, of course, we don't know the height, that's the thing we're being asked. And all we know is that the whole line from one end of, well, from Sherry to Leo, we know that the whole line is 36. We don't know how it splits up, right? Is it that one side of it is maybe 20 and the other side of it is 16? Or is it that one side of it is, I mean, we don't know. We really don't know. All right. So let me give you a little bit of a starting point then, right? we'll call that missing side x. That's what we really are trying to find. I'm going to split up that bottom side. We don't know what each side is. We don't. We just know the whole thing is 36, right? What if we made one side of this y? Let's call this side here y, right? So the side on the left is y. What would the side on the right be in that case? All right, so one side of that line would be y. What would the other side be? Can anybody help me out with that? Excellent, 36 minus y. Okay. Good. I think that's a good start, actually. Because no, here's what I'm thinking. I can come up with an equation that uses that angle of pi over 4 on one side and pi over 3 on the other to come up with an equation that has x, and then the x is in both, and then we can probably then set them equal to each other. Here's what I mean. Let's take the triangle on the left for a minute. The triangle on the left, I can use, let's say, tangent of this angle, pi over 4, is equal to x over y. Can we agree on that, first of all? Opposite over adjacent? All right. By the way, thank you, Noah, Karis, and Emily. Thank you for that input. Can we agree on that? That the tan of pi over 4 is equal to x over y? Okay. What is the tan of pi over 4? Look it up, folks, if you don't remember. What's the tan of pi over 4? Because that has a value. We can actually find that value. What's the tan of pi over 4? It's one of those special angles. It's 1. Thank you, Rachel. Thank you, Joel. 1 equals x over y. You know what this means? If I were to isolate the x, what is x equal to in that case? If I were to get the x on its own, what's x equal to? Since 1 is equal to x over y, x is equal to y. And the fact is that this triangle on the left is actually an isosceles triangle. Right? Pi over 4 in each corner. The one on the right is not an isosceles triangle. The one on the left is. Okay, let's go to the one on the left now. Can we also come up with a tangent of pi over 3 and set it equal to something? What would the tangent of pi over 3 be equal to, based on SOHCAHTOA? X over 36 minus, yeah, okay. Can we all agree on that? Jeremy and Harish have said that, and I wonder if everybody agrees with that. Good. Do we know the tan of pi over 3? Can somebody look that up for me, please? Tan of pi over 3, what is that? Okay, I'm seeing Jeremy saying it's the root of 3. Okay, all right. Can we agree on that? Does that make sense to everybody? Root of 3 makes sense to everybody? All right, okay. Now I'm thinking, this could be a case where we could do a substitution, because whatever the x and the y are over here is the same thing over here, right? So I could either substitute a y for the x or an x for the y and solve for the thing that we don't know. Now, because I'm trying to solve for x, which one makes more sense for us to substitute into this? Y is equal to x. Now, we're told that. So which one should we substitute into this? Anybody? Does anybody have an answer for that? Sub the y equals x. So you're thinking that I should take out the x and put a y in, or take out the y and put an x in? Which one is a better solution? Replace the y with an x. Okay, all right. So root 3 is equal to x over 36 minus x. I happen to agree with that. It sounds like we might be able to solve this. But we still haven't isolated the x. So we need some more work. We need to do some more work. Can anybody suggest another step? Root 3 on the left is equal to x over 36 minus x. Multiply both sides by 36 minus x. Okay, okay. So root 3 multiplied by 36 minus x is equal to x. That sounds like what Jeremy said. Would you agree, everybody? Right? Does everybody agree with that step? That's like cross multiplying. Karis and Sharisa say, okay, good, Eva, great. So what do you think happens next? Thanks, Krista. Thanks, Eva. Thanks, Sharisa. Thanks, Karis. I appreciate all of you chiming in. Right? Expand the left side. Okay. What would I get if I expanded that left side? What would I get from doing that? Tell me what the terms are that I would get from expanding that left side. 36 root 3 minus x root 3. Okay. 36 root 3 minus x root 3 equals x. All right. Notice that we don't have any decimals anywhere. We don't want any decimals. This has to be all exact. All right. Over to you again. Jeremy has done a lot of the work. Where's everybody else? What do you think needs to happen next? Let me give you a hint. Let's get all my x's together, folks. X's like to stick together. X's want to be with other x's. That's my clue to you. What do you think I need to do? What do you think? Let's see what Harish says. Bring the minus x root 3 to the right side. Travis agrees with that. Jeremy, is that what you wanted to tell us? Okay. So 36 root 3 is equal to x plus x root 3. Okay. I still don't know what x is. I still need to have an x equals. So I'm waiting for you again. What can I do now? I think I know what to do next. All right. Okay, Jeremy, what do you think we're going to do next? Like square the two sides? I'm not sure how useful that might be, though. I think I know what you're trying to get rid of. I know what you're trying. You're trying to get rid of square roots. I get that. I understand that. And what's going to happen though is that you're going to end up with x squared on one side, and I don't know. I'm not so sure about that. All right, so let's see if we can think of something else. I'll give you a hint. On the right side, there may be a common factor. What is that common factor? Okay, Jeremy thinks it's x. Is he right? Is he right? Is that the common factor on the right side? Okay, let's factor it out then. What's left inside of that? What would be inside of that bracket if I factor that out? So 1 plus root 3, okay. So Jeremy's right. Harish is right. Okay, Jeremy said 1 minus root 3. Where did that come from? Oh, you changed it. 1 plus. Okay. All right. So does it kind of suggest what my next step probably should be then? I'm trying to get the x on its own. Remember, that's my goal. right? I want that x to stand alone. I don't want anything on that side with the x. Divide both sides by 1 plus root 3. I like that. So that means the x is now on its own, which is great. So this is in exact form. Now, some people would say that we could go a little further than that by rationalizing the denominator. So maybe we feel a little adventurous. I mean, I would accept this answer. Let me just say that I'd accept this answer as long as you put, was it centimeters? I think meters. So this thing in meters, and then you put a statement. The height of the balloon, I put a statement here because I'm expecting this of you, of the balloon. Of course, I might want to spell balloon right. I might want to do that. Is 36 root 3 over 1 plus root 3 meters high. Or just meters. I don't think we need to say meters high. What do you think will be the best way for us to get started with this? It's tan x over 1 plus secant x plus 1 plus secant x over tan x. Add them together. Like a common denominator, you're thinking? Yeah, that might be a good idea, but the first thing I would do is I would change that tan into something else. And I change that secant into something else. That's what I think. Make the denominators equal to each side. All of that's great, but tan and secant can be made into something else. Can they not, Harish and Sai? Thank you. Thank you very much. So we're going to do that first. So that's equal to, let me go back to black. So that's equal to sine x over cos x over 1 plus 1 over, ooh, that's ugly, hold on, over cos x over 1 plus what Kristen just said, 1 over cosine x. I'm going to do the same thing over here. 1 plus 1 over cosine x over sine x over cos x. Okay, let's see what Jeremy is saying now. They can. What do you mean they can? Meaning what? Tell me what you meant by. Oh, Axel's asking. Yeah, make this okay, yeah, okay, good, good, good. All right, so now that we've done that, any more suggestions? Any more suggestions? Yeah, go for it, Jeremy. Good, and we can do that. That would be useful for this fraction here, this one here. That would be useful for this one over here. So we'll do the same thing for both. All right, so let's do that. So the top is still sine x over cos x. But the bottom now is going to have a denominator of what? What's the common denominator between those two? Can anybody tell me what that is? It's 1 plus 1 over cosine x. What's the cosine x? Okay, so cosine x. And if on the top I had, this is like 1 over 1, this would become, hopefully you'll agree with me on this. What do I multiply that 1 by to get the cos x? Would be cos x plus 1. Okay, and I can do the same thing over here. All right, since it's the same 1 plus cos x, I'm going to write this as cos x plus 1 over cos x. All of that is over sine x over cos x. Okay, Now, let me ask you to focus on something here now. Let's focus on the first part of this. Look at the first part of this, the part I'm circling right now, right? How do I divide a fraction by a fraction? Does anybody remember how we do that? Dividing a fraction by another fraction. Do you remember how we do that? Multiply by, thank you very much. I'm going to do that. And we'll do that for both of these, right? So this is going to become sine x over cosine x multiplied by the reciprocal cosine x over cosine x plus 1. That's for that one. And over here, it's going to be similar. It's going to be cosine x plus 1 over cosine x times cos x over sine x. Okay, I'm hoping that everybody agrees with what I just did. I took the top of this fraction over cos x, and I multiplied by the reciprocal, which is cos over sine. I did the same thing over here. Okay, can anybody tell me what they think is going to happen to the left hand, to the first one, this first one here? Anything we can cancel out? Anything, what do you think is going to happen here? Cancel out the cos x is good, good. So I'm going to end up with this sine x over cosine of x, sorry, that's rubbish, ignore that. Ignore that completely, please. Sine of x over cosine x plus 1. And on this side, I'm going to cancel the cos x again. So I'm going to get cosine x plus 1 over sine x. Can we agree on that? I just want to check with the room on that. Does that look like that kind of makes sense? It's, in fact, both of these are kind of, because originally this was the reciprocal of this, right? Tan over sine 1 plus sine secant x, 1 over secant x plus sine. It makes sense that when we're here, that these two things are just reciprocals of each other. All right? So what do you think, folks? What do you think I'm going to do now? What do you think I'm going to do next? Anybody? Nobody? I have these two fractions. Make the denominator equal. No, not don't make them equal. I think what you mean by that is get a common denominator. Is that what you mean, Harish? In the few minutes that we have left. So I'm going to say, what is that common denominator? Can anybody tell me quickly what the common denominator is? What is the common denominator? What about 6 minutes left? Anybody what the common denominator is? Anybody? 1 plus cosine x. Yeah, good. Or cosine x plus 1 multiplied by sine x. Right? And then on top, we're going to have, hopefully everybody understands this, we're going to have sine times sine, which is sine squared x, plus we're going to have cos x plus 1 all squared. We're going to actually square that up. All right? So I'm going to go a little bit faster now. Sorry, folks. I'm going to go a little bit faster. So this is sine squared x plus, I'm going to have to expand this. When I expand this, it's like cos x plus 1 times cos x plus 1. I'll tell you what I'm going to come up with because I'm trying to do this really quickly. I'm going to get cos squared x plus 2 cos x plus 1. And you can do that more slowly for you to make sure you're getting the same thing that I'm getting. And all of that is over cos x plus 1 times sine x. Okay, can we tidy up the top? Yes, we can. The sine squared x plus cos squared x is, what is that again? Sine squared x plus cos squared x is what again? It's 1. Okay, so it's 1 plus 2 cos x plus another 1 over cosine of x plus 1 times the sine of x. And the top of this can be simplified. Hope everybody can see that. It's going to be 2 plus 2 cosine x. This is going to be all in the recording, so you can all review this more slowly later on. All right? So it's 2 plus 2 cosine x over cos x plus 1 times sine x. Does anybody see something we can do at the top very quickly? Anything we can do at the top? Anything we can do at the top? 2 plus 2 cosine x. Factor out the 2. Thank you very much. Factor out the 2. I'm going to get 1 plus cosine x all over cosine x plus 1 times sine x. In brackets again. Can I reduce anything? Does everybody agree with Jeremy on that? That I can cancel out the 1 plus cosine x. Cosine x plus 1 and the 1 plus cosine x is the same thing. Okay? So I'm left with 2 over sine x. Right? The cosine x plus 1, yes, can be cancelled out. Thank you, Travis. Right? So what is this actually equal to? Right? Because I wouldn't accept this answer as your final answer. Well done. No, Harish, not what you just said. It's what Joel just said. Sorry, that should be an equal sign. So it's equal to 2 secant x. Right? Because 1 over sine is, oh no, sorry, cosecant. Whoa. Sorry, that's rubbish. That's what happens when you rush. This is what happens when you rush. 2 cosecant x. Right? The reciprocal of sine is cosecant. So it's actually 2 cosecant